yesterday because this is going to be used again today. So direct relationship, direct variation. It's y equals k times x. Direct variation is going to be, k is just some number, right? Which would be the same in every equation for the situation you set up. K is just going to be a number, but it's some number times your variable x. And then just as a piggyback on this, I'm just transforming this equation a little bit. If you needed to find the k value, what you would do to that equation is divide both sides by x. So just transforming this a little bit, the k value, or your constant of variation, is just y divided by x if you need to figure that out. The inverse variation is going to be a fraction. So it's going to be y equals some number k over x. That k would be the same for every situation you were working with. In that problem, the x could change. And same thing there, just to transform that equation a little bit, if you needed to find k, what I would do there, I would multiply both sides by x to get it out of the denominator. So for an inverse variation, the constant of variation k is x times y. So you can multiply the x and y coordinates like if we had a table or something, or if we have an equation, we can just multiply those from the given information in the problem. Okay, we're going to add into the mix today what we call a combined variation. They're basically just a little bit more enhanced versions of what we did yesterday. So a combined variation is more than one variation in the same equation. Just more than one. So it might say something to you like varies directly with this and inversely with that. So you might have two things going on in the same equation, or three things going on in the same equation. So it's just going to be a little bit enhanced from what we did yesterday. Another word you're going to see today in a couple of these is going to say varies jointly, or a joint variation. So if you see varies jointly is how that's going to be kind of described in the problem. Excuse me. This is a direct, so it's going to be multiplication with your k. All right, so it's a direct relationship, but it's with two or maybe more variables. So if you're reading a problem and it says varies jointly, think about that as, bless you, direct relationship. It's just going to be like two variables multiplied together, or maybe three variables multiplied together. But jointly is just multiple variables multiplied. Okay, so just a couple examples to kind of illustrate this for you guys. The one main thing people screw up when they start to set these equations up is they don't put a k value in, because you're not going to get that from the description, but you need it to actually do the problem. So when I do, and I put don't forget k right above these little tables, what I'm going to give you is a description. We're just going to translate it to an equation. So let me just start here real quick. This one says y varies. So I would literally just write y equals. Varies turns into an equal sign. Okay, now this is directly with the square of x. So it's different than what we did yesterday, but similar. How would I write directly with the square of x? First thing I would definitely not forget is I'd want to put a k in there. How would you write the square of x? Like, what would you translate that into an equation as? X squared. Done. That's it. Right there. And it's more complicated than yesterday, so it doesn't fall into the direct category exactly. It's just going to be a little more complicated because it's called a combined variation. Okay, now I'm going to write this one. This says y varies inversely. So y equals inversely with the cube of x. If you've got inverse, then you've got a fraction. So we're going to put the k on top, and inversely means that variable should be in the denominator of a fraction. So how would you write the cube of x? X cubed? That's it. X to the third? That's it. So those are pretty similar to yesterday. These other two are a little bit more complicated. Okay, this one says z varies. So z equals. Now, right after that equal sign, I better be putting a k. Now, this one is that one right above jointly. It says jointly with x and y. X and y, that's all it means is to multiply those together. So this would just be kxy, just like that. Jointly means whatever follows the jointly gets multiplied together. And I got one more. See if you guys can, this one's the most complicated. See if you can figure this out. So it says Z varies jointly with X and Y and inversely with W. How would I set up the other side of that equation? If I'm going to go jointly with X and Y and then inversely with W. Perfect, perfect. Okay, so I'm just going to do KXY on the top, and then you just put W on the bottom. Perfect. Does anybody have any questions so far? Okay, let me scooch this up a little bit. Now, this is going to kind of work backwards from what I just did. I'm going to give you, these are actual formulas. I'm going to give you the equation. We're going to see if we can write it out in words, kind of like I had described above there. So these are actual formulas. This one that's first written here says the mass of a moving object is related to its kinetic energy N, velocity is speed V by this formula. So you don't want to have the K in your description. You should not see a number in your description. But I do at the end of each one of these ask, or like on the side there, ask you what the K value is. Can anybody tell me for this equation, I've got M equals 2N over V squared. What would you tell me the K value is? Just the 2. Just the number is going to be your K value. That is not going to be in the description at all. Okay, now you don't have to write the words out, like this is mass and kinetic energy and all that. Don't write the words out. I'm just going to use the variables. Okay, so mass here, I'm going to write M varies. The equal sign is going to turn into the word varies. Do not put 2 as part of the description. Okay, then I have on the top of that 2 times N. So if you're multiplying by your constant of variation here, I'm going to say directly, because there's just one variable, just N, directly with N. And then I've got a variable in the bottom, that's V squared. So that's going to be, if it's in the bottom, inversely. So then I'm going to say inversely, hopefully spelling that correctly, with the velocity squared. I'm just going to put V squared. I'll just go ahead and put the variable. So directly with N, that's in the top, inversely with V squared. The second example I have here, this is volume of a sphere, so for geometry. Okay, so volume is 4/3 pi r cubed. Can anybody tell me what the constant of variation would be for your sphere? Like, what would you always use in the formula for a sphere? What would your constant of variation be if you're looking at that formula?
4/3.
4/3 is part of it.
4/3 pi.
Yes. Okay, that's super tricky there. You would always use 4/3, and pi is a number, right? It's got a symbol for it, obviously, but pi is a number. Anytime you found the volume of any sphere, the only thing you need is the radius. You don't need the 4/3 pi. That's the constant of variation because it's constantly in that formula. So that's not part of your description. The only thing we're going to do here, or just volume, I'll just say V, varies. And then the only variable you have here is the radius of the sphere. So this varies directly because that's being multiplied by your K value with radius cubed, or I'm just going to put r to the third so I don't have to write that. With the 4/3 and the pi, that's your K. That's not part of the description. The last one's area formula for a triangle. This is kind of tricky. Can anybody tell me what the constant of variation is if you're finding the area of a triangle? It's not 2. We think it's 1/2. Yeah. So another way you guys maybe have seen this, if you were in geometry, they might write it as 1/2 base times height. But I don't have an inverse relationship here because I do not have a variable in the denominator. The 2 variables are on top of that 2. So if you want to think about pulling that to the side, that's a 1/2 is what I'm multiplying by. Now, these 2 variables are both being multiplied. So it should be a direct relationship, but because there's more than one variable, you have to use that word jointly when you describe this. So it would be area, I'm just going to put A, varies jointly with the base and height, which I'm going to just put B and H. And it doesn't matter the order that you put those in because you're multiplying them together. So if you wanted to put H first and B second, that would be the same thing. But jointly, if you've got more than one variable being multiplied by your constant variation. So I've got base and height being multiplied by the 1/2. Is anybody having a question about writing those out? Now, the rest of these, we're going to set up equations, and then they're going to give us some information, and we're going to find some answers. You might want a calculator. A couple of these don't have the nicest of answers as we go through. So, see if you can translate this for me into an equation. Don't look at the numbers. I'm just going to look at the very, very first part of this, where it says y varies jointly with x and z. And just as you think about this, don't forget you have to put the k in, which we won't know for a second, but we have to make sure we represent that when we write our equation so we can solve for it in a second. How would you write y varies jointly with x and z? Like, what would the equation look like? Y varies jointly with x and z. Perfect. Okay, so y equals kx z. That's my general setup. Now, the way these work, they're going to give you just enough information to figure out the k value, what the constant of variation should be. It should just be a number. So it's going to say here, if y is 5 when x is 3 and z is 4. And I'm going to stop right there as I'm reading that. That is giving me all the variables except k. So I'm going to use that to plug into the formula we just set up here. All right, so in place of the y, I'm going to put a 5. K is what we're trying to figure out, so that's going to, I'm just going to leave that as k. X is 3 and z is 4. So if I'm just solving this, and this is not a nice answer, but that's okay. So 5 would be k times 12. 3 times 4, you can go ahead and do that. I'm going to divide by 12, and my k value is 5/12. So I'm just going to leave that as a fraction. So let me come back over here. So my general form, if we do any other problems in this situation, the k value is 5/12. So I'm just substituting that back in. So y equals 5/12 times x times z. Then this is really similar to what we were doing in our last lesson. They're going to ask you a secondary question. Basically, once you figure out that k value, find something else. So this one says, find y when x is 6 and z is 8. We have all the information we need to do this. I don't know why. The k value is that 5/12 we just solved for. X is supposed to be 6 and z is supposed to be 8. And we can just put that right into the calculator. You do it by hand if you want to. So I'm going to do 5/12 times 6 times 8. And I'm going to end up, actually this is a nice answer, y is 20. This is the actual answer to the question, but we had to do all that work to be able to get to that place. We had to set up the equation, find the constant, and then you're actually going to be asked to use that equation to find something else. In that case, it's going to be y. Is anybody having a question so far? Now, each one of these is just a little bit different. So see if we could set up this one. This says, don't forget your k when you think about doing this. This one says y varies directly with x squared and inversely with z. How would I write that into an equation? Y varies directly with x squared, inversely with z. What do you think? Perfect. Y equals kx squared over z. All right, so there's my general form. Now, they're going to give me just enough information to figure out the k value. So that's going to come here. It's going to say if y is 12 when x is 2 and z is 7. I'm just going to stop right there. Plug that information in to figure out my k value. All right, so it says y is 12. So I'm going to put that in for y. K is what we're going to solve for. So I'm going to leave that alone. X is 2. Now, as we set this up, it said x was squared. So I'm going to have to take 2 and square that. And then inversely with z, so the inversely is going to go on the bottom, so the 7 is going to go on the bottom there. Okay, what I would, and you can do this in however you want, I would just maybe multiply by 7 real quick to get that out of the denominator. You're going to get 84. and 2 squared is 4. So I'm going to simplify that just a little bit. So I'm going to multiply both sides by 7, get rid of the fraction there. And then ultimately, I'm going to have to take 84, divide that by 4, and that'll give us our k value, which ends up being a nice answer here. This ends up being 21. Now, I'm just going to real quick go back to where I was at, where we wrote this initially. So for our situation here, this would be y equals 21x squared over z. So we now know the constant of variation is 21. Then they're going to ask you this secondary question. So they're going to ask you to find, let's see, we're going to find y when x is 3 and z is 9. So I don't know y, so that's going to be my variable. My k value is 21. They're telling us to plug in 3 for x, that's going to get squared. And then z, they're telling us to plug in 9. So I would just, you just write on your calculator. I'm going to do 21 times 3 squared. That's the top of the fraction. And then I'm going to divide that by 9. And actually, y is going to be 21 here. So it's kind of like 2 questions in one. You got to set up the equation, and then you got to use that equation to find something else. Is how these are usually going to work. All right, and I got one more. All right, now this one's probably the trickiest of all. So this one says y varies jointly with the cube root of x and z squared. Can anybody translate that into, like, what would the equation look like just to set that up? Y varies jointly with cube root of x and bless you, z bless you squared. How would you write that into an equation? And don't forget k. How would I set that up? Perfect. Yes, jointly just means multiplication, and it just looks kind of complicated because I've got that cube root and I've got the z squared. If you wanted to do x to the 1/3 power, you could do that too. I would just do cube root. It doesn't matter, honestly. And if you do get a square root or a cube root, I'm going to give you a nice number to plug in for that for any of these questions. So it's not going to be a nasty decimal from the cube root anyway. You might have a fraction or something, but not from the cube root. Okay, so there's our general form. Then they're just going to give us just enough. It says y is 3 when x is 8, z is 4. So we're just going to plug that info in. So 3 goes in for y. I don't know k. That's the whole purpose of them giving us this information, is so we can figure out the constant of variation, which is k. Okay, I'm going to do cube root of x. So it'd be cube root of 8. And then z squared. Z is 4, so I'm going to have to square that. Anybody remember from radicals unit, what would the cube root of 8 be? 2. It's a nice number. And then 4 squared, just 4 times 4 is 16. So if I simplify that just a little bit, that's going to be 2 times 16 is 32. Now, our k value here, you can probably see, is not going to be a nice value, but that's okay. I'm just going to leave it as a fraction, though. I'm going to divide both sides by 32, and then k would be 3 over 32. It's not a nice decimal, so let me just sub that back in. So our general form here, 3 over 32, cube root of x, and then z squared would be what we would want to plug in for any further questions they're going to ask us. Okay, now, just enough. They're going to say find y when x is 27 and z is 6. So I don't know y. I know the k values, our constant of variation, is going to end up being 3 over 32 for this problem. Then we're going to do cube root of 27, which I promise is a nice number, and then z squared, which is going to be 6 squared. So don't forget to square that. Don't forget to take the cube root of the 27. All right, if you guys, you can type this right into your calculator, but if you want to simplify this a little bit, cube root of 27 is just 3, and 6 squared is 36. That might be couple less buttons to push on your calculator, but I'm going to do 3 divided by 32, multiply that by 3, multiply that by 36, and I'm getting 10.125 is going to be my y. So that all that to get that answer to the question there. These are kind of, they just end up being 2 problems in one. You got to set up to figure out the constant, and then once you got that, they're going to ask you to use your equation to find Is anybody having a question? Okay, now the rest of these are similar, but we're going to set it up from a word problem instead of kind of being a little bit more straightforward than the example we just did. Okay, so this one says, in an elementary school's 3rd grade class, number of girls, so let me just use a G, bless you, varies directly with the number of boys and inversely with the number of teachers. Okay, so directly is going to be K times that variable. So directly with the boys, I'll just use B for boys, and inversely means that variable's going on the bottom of a fraction, inversely with the number of teachers. So my general setup here, girls, number of girls varies directly with the number of boys and inversely with the number of teachers would look something like what I have up there. And you could use different variables if you want, but that's what I'm going to use for my example. Okay, now it says you've got 50 girls, so I'm going to plug in 50 for the G. I don't know the constant of variation here. When you have 40 boys and 3 teachers. Now, if it's me, I would just multiply both sides here by 3, get that out of the denominator real quick. This is not the greatest number ever, but I'm going to get 150 equals K times 40. So you're going to take 150, divide by 40, and K is going to be 3.75. Okay, now my secondary question here. It says if next school year's 3rd grade class has 64 girls, so I'm going to put 64 in for the girls. I know the K is the 3.75, and then I have 66 boys, so I'm going to put 66 in for the number of boys. How many teachers do I need? So the teachers there are going to be the variable. A couple ways you could do, if you guys want to turn this into a proportion, you could do that real quick, or I might just, if I just multiply both sides by t, get that out of the denominator real quick, then I'd have 64 times my number of teachers, and then I'm going to take 3.75 times 66. This is 247.5. This is not going to be a nice number when I do this. I'm going to divide by 64. I'm going to get t approximately, I'm going to round this, about 3.867-ish. So if I were to ask you this question, how many teachers do I need, what would you tell me? 4, because we can't have part of it. Well, hopefully we can't have part of a teacher. Okay, so they have state laws about how many kids you can have in a room per adult and things like that. So this would have to be something where they would figure that out. So you have to round it up to 4. Anybody having a question about how I set that up? Okay, let me scooch this down. This one says, restaurant prepares a salad. The number of strawberries, I'll just use S for strawberries, varies jointly. So that jointly is going to be multiplication, whatever follows, with plums and tomatoes. Okay, so I'm going to go K for my constant of variation. I'll do P for plum and T for tomato. So since strawberries in the salad varies jointly, means multiply together with plums and tomatoes. Okay, then they're going to give us just enough information to figure out our constant of variation here. So they say we got, holy cow, 500 strawberries, this must be a huge salad, are needed if we have 4 plums, so I'm going to put that in for P, and 25 tomatoes. Now, if you simplify that just a teeny tiny bit, 4 times 25 is just 100. So if I'm trying to get my constant there, I just have to take 500 divided by 100, so that's just going to be 5. All right, then they're going to tell you a different salad we're going to make, which is much smaller apparently. It says how many plums are needed if you've got 40 strawberries and 2 tomatoes. So in for the strawberries, I'm going to put 40. My constant of variation is 5, so I'm going to go ahead and put 5 for the K. And we're solving for the number of plums, so I don't know that. And it says the number of tomatoes is 2, so I'm going to put that. All right, if you want to, you can simplify just a little bit. 5 times 2, you can go ahead and do that, would be 10 times the number of plums there. And then this will be a nice answer. I'm just going to divide by 10. So number of plums I'm going to need is going to be 4. And then I have one more problem at the bottom. Is anybody having a question? Okay. This one says the number of students, let's just use S, in a high school varies jointly with the number of teachers and the number of administrators squared. So an administrator is like a principal or a vice principal or something like that. So I'm going to do K here. Number of teachers, and then administrators, I'll just use A, and that's supposed to be squared. So something like that. Number of students, got to hear my constant variation. Jointly means we're going to multiply together the teachers and the administrators squared. Okay, let's see what they're going to give us here. You got 1,000 students are present when we've got 40 teachers and 2 administrators. The administrators, you have to square that number. So I'm going to get 1,000 equals, let's see, 40 times 2 squared would be 40 times 4, so that'd be 160. So to get our constant here, we're going to take 1,000 divided by 160, and it's not too bad of a decimal. So 1,000 divided by 160 is 6.25. And then it says how many students are we going to have if we've got 60 teachers and 3 administrators? Okay, so do not know the number of students. I know the constant of variation here is supposed to be 6.25, and then I'm going to multiply that by the number of teachers, which is 60, and the number of administrators, 3, but that gets squared because it's number of administrators squared. So it's going to be 6.25 times 60 times 3 squared, which would be 9. So this would be 3,375. Is anybody having a question?
Read this squared from.
So it says right here, the number of administrators squared.
Oh.
Yeah, that's tricky.